Greetings, everyone. For those, who are joining us, thanks for making the time. Obviously, we're from Stage Audio Works. We're a supplier and systems integrator of professional audio, video lighting solutions, serving a lot of different industries like houses of worship, rental staging, theaters, etc. This is the second part of our basic audio series. For this, I'm joined by some of my colleagues, Udo and MCF from Namibia, and Ross from Durban. And they've put a lot of work together putting this series, 4 parts. So last time we started with kind of audio physics. Now we're going to actually dive into audio equipment, or electroacoustic equipment, as they call it.
Cool. How's it, everyone? I'm Udo. I'm here in Namibia. I'm going to do most of the talking, like Nathan said. So last time just to recap a bit quickly. So this time we're going to speak about the basics of a sound system, what that entails. And MCA took us through a few basic principles, like what is sound? If you would think about it, what is sound? The displacement of particles in air, water, or glass that creates a vibration, a compression of moving particles, and that creates waves, audio waves. And we call that the amount of waves per second, we call that frequency. And you get sine waves, which is usually what audio waves are. So if you see the graphs, like an EQ graph, it's kind of, it represents sine waves, audio, physical audio. Complex with fundamental tones and harmonics. So it's not just one wave of a sound. So if you hear an instrument playing, it's usually a complex mix of tones and overtones and harmonics that work together. And frequency and wavelength determine the pitch of a sound. So frequency is the amount of waves per second, and then the wavelength is how long the wave is. So basically, the longer the wave, the lower the sound, and the shorter the wave, the higher the sound, the pitch. And then amplitude, when we speak of amplitude, we mean the volume of the sound. So amplitude is, as you see here, so amplitude is the kind of on the graph, if you look at this graph, the height of the sine wave, and then wavelength that we measure in lambda, this is lambda, is that determines the pitch of the sound. So very interesting audio principles. Speed of sound is 343 meters per second. So if you measure that in kilometers per hour, that would be about 1,234 kilometers per hour. It depends on temperature. So at 0 degrees Celsius, it's 341 meters per second, apparently. And at about 20 degrees Celsius, sound travels at 343 meters per second. So our human hearing, we can only hear between 20 cycles per second, so 20 hertz, and up to 20,000 hertz. That is the ideal range of, probably if you're a baby or younger person, you can probably hear up to about 18,000 hertz. But as older chaps, we probably can only hear up to 16 kilohertz. I think my top is 14 at the moment because of some hearing loss there. So and then MC spoke about the EQ graph. So just the way we see sound on DAWs, and then wattage versus sound pressure level. So usually what MC just mentioned there was that it's good to look at sound pressure level, SPL. SPL is the pressure that the sound waves cause, and that's determined by distance away from the sound system. So if you see SPL levels on a say a speaker diagram, like a spec sheet. Rather look at the SPL level that the speaker can produce, because that gives you a bit of a better indication of how loud the speaker can go. Cool. So that was last week. This week we're looking at what is a sound system and the basics of sound systems. So if you would think of it in technical terms, a sound system is a combination of gear, a combination of equipment that reinforces sound. So sound reinforcement tools that amplify audio. So most of us speak of a PA system. PA stands for public address systems. So that is kind of the conventional term used, but you can also say sound reinforcement system or amplification. So that is what we're going to look at today, the basics of it. So if you would think of a definition of a sound system, try and think of what are the basics of a sound system. And if we look at that, it's basically sound input that so the physical wave needs to be kind of converted into a electrical wave, and then we're looking at sound manipulation and amplification and sound output. So that is the kind of basics of what a sound system should be able to do. Let's just look at some brief history when it comes to sound systems. I think this is very interesting. I know when we speak of history, sometimes people are like, oh no, man, sounds like high school. So when it comes to sound systems, before we had sound systems, we had basically the way you would address the public or the way you would perform is just through architectural acoustics. So the architecture that you were in would determine how much reverb there is and would in a way amplify the sounds created on stage. So that's been hundreds of years before the 1900s, that the way that people would perform and would address the public. So then in the 1800s, late 1800s, there was this guy, I believe his name was, let's just see here, David Edward Hughes and Alexander Graham Bell. You guys have probably heard of Alexander Graham Bell, who invented the telephone, and together with the telephone, the first microphone was created, but it wasn't that practical of a system. So then they went over to a carbon microphone that was invented by, in collaboration or independent from each other, David Edward Hughes in England and Thomas Edison and Emil Berliner in the US. They developed the carbon microphone. It's just a basic structure of two filaments there. Okay, so in 1906 we had the first amplifier. That's what I think that amplifier that you see there is from 1914. That was developed by Lee DeForest, and it was a tube amp, 1906. And then in the 20s we had the speaker. I believe that's one of the first production speakers in the 1920s, I think 26. Okay, so with the development of the sound system, we had a development of musical instruments. And with World War I, you had a lot of guys that were looking for entertainment, but you didn't have the kind of money to as they used to have big bands in the 20s. They had big bands, I believe, still. I think World War I was 1917 to 1919. But in America, you had this progression of music from blues kind of developing into jazz, which became the popular music in the 20s. And people wanted to hear more of it because there was now, we had the development of the radio, and we had the development of, so in the 1900s, the gramophone and the phonograph. So these things help people to independently from each other to receive music, and to become a fan of a music group. And so music became more popular, and jazz was the popular music of the time. And so in the 30s, we had the electric guitar. And at this stage, we had individual amplification on stage. So now, with the development of all this technology, you had people on stage, the performers, they now had amplifiers to amplify their sound, because if the crowd was getting a bit larger, then you needed to amplify your instrument. So that's an interesting development there. Of course, we all know about rock and roll and the electric guitar in the 50s as well. So we had rock and roll in the 50s, and music became louder, and all of a sudden you had these groups that had thousands of fans, and maybe millions, as we will see now. Like the Beatles, they used small PA systems. One really significant concert was the Shia concert at the Shia Stadium, where the Beatles performed to, I believe, about 56,000 people. So you can imagine, with 4 guys on stage trying to amplify themselves with a backline, 56,000 screaming, I guess like 40,000 ladies, girls screaming, and a lot of people screaming at you. You're not going to be able to hear what's happening on stage. So they had 4, just for interest sake, they had 4 175 watt amplifiers. So in today's terms, that's not a lot, especially when you perform to a group that size. Okay, so then in the 70s, we had these super groups that started performing. We had, end of 60s, we had Woodstock, which is another major event when it comes to the development of the sound system, because they catered for, I think, about 200,000, and eventually, I think between 400 and 500,000 people showed up for this concert for Woodstock. So they saw that there's a growing demand in amplification, and so there were these guys, Bill Handley. He developed he built that sound system for Woodstock, and then we had that major concert with the Grateful Dead and the band called The Band. I don't know if you guys know The Band. I love The Band. And they were playing to about 600,000 fans. And this is where you had the development of the triple system amplification. So this is now kind of what we have up to this day, where you have the backline, which is your instrumental amplification. You have the monitors on stage, and the front of house, the PA system. So that is the triple system amplification. And then the modern era, we're looking at the 2000s here. We moved to a stage of having a silent stage on at concerts, where it's basically, if you have acoustic drums, then it's only the acoustic drums behind perspex that is still not amplified. So now we have in-ear monitors, we have pickups, and so you have a silent stage, which is nice to work with these days. Yeah, that's the development of the sound system. Let's look at the basic parts of a sound system. So you have the input stage, will have the microphone or input transducer. So this is where the sound comes, where the signal starts, the signal chain. You have the some sort of signal manipulator after the input transducer. Then you get the amplifier, which picks up the signal, and the output device will be your speakers. So those are the very, very fundamental parts of a sound system. If you think of signal path, I don't know who of you have heard the terminology signal path or signal chain. Basically what you're looking at is the path the audio takes from input to final output. So that's called that's your chain. It's good to know this when you start setting up sound systems, so that you can always follow the inputs and outputs of your equipment. All right, so you get your input stage, manipulation stage, your amplification stage, and your output stage. That's your sound system. Okay, so let's look at these in depth. Sound input. Okay, that's your first stage in the chain. It's the physical sound wave being created by either an instrument or somebody singing or speaking. And this physical sound travels through the air and needs to be picked up by a transducer, usually a microphone or a guitar pickup or something like that. And these transducers convert your input, your physical sound, into electrical sound. Okay, so they're called input transducers. So if you hear that terminology, you know what you're talking about. And it's like a microphone and pickup in other instruments. Okay, so the next stage is audio manipulation. That's now when your sound travels, your electric sound travels to either a mixer or some sort of effects unit. And that's the stage where you basically manipulate your sound waves. So the electrical energy can be manipulated to either do gain staging or volume gain staging or effects. So like reverb, compression, EQing, and panning, those kind of things. So we are able to manipulate the sound at this stage of the signal. Yeah, and you can also send to auxiliary channels, maybe to your monitors or to your recording device, things like that. Okay, so the next stage is audio amplification. So you get a device that now takes this quite weak signal that you get from the mixer or from your manipulation stage, and basically what the amplifier does is it takes this weak electrical signal and it boosts it with external electrical power to be able to drive the speakers. So you need the amplifier to, obviously the bigger the speaker, the bigger the more power your amplifier needs to drive that signal. Okay, cool. So usually you get the amplifiers in standalone units or built into a speaker. So active speakers have built-in amplifiers to boost the signal coming in, and passive speakers need an external amplifier to boost that signal. The next stage we're looking at is sound output. So that's pretty much your last stage. Your speakers, so you get different types of speakers, your tweeters and your bass cabs. They need to be driven by the amplifiers, like I said, and they've got this diaphragm that pushes so there's a magnet that's being driven by this electrical sound, and that pushes and pulls on this diaphragm here to push air out and convert the electrical energy into acoustical, physical sound waves that we perceive as sound. Cool. So one interesting fact here that I wanted to mention is, I'm not sure if you know this, but back when they developed the first speaker in the 20s, I can't remember their names. I think Kellogg, one guy's name was Kellogg, and what they did is, before they had this the conventional speaker that we know today, they had these few kind of prototype models that worked with the one was an electrostatic speaker, and it was as big as a door. And what they did is they used pig intestine to create that diaphragm. So this diaphragm that we now see in modern speakers was firstly a pig intestine diaphragm, but you can imagine that it started rotting and wouldn't last long. So they didn't have an option with that one to commercially produce it. And then later on, I think in the 30s, they had a synthetic material to produce this diaphragm. So that's what we've got up to this day, is the synthetic material. Your speakers are your output transducers. They drive that electric energy to physical sound waves, and that will be the end of your signal path. But remember that ultimately, if you are a sound engineer or a musician, the ultimate signal path is obviously from the musician to the audience. Great stuff. So So the speakers are your sum of your input and manipulated audio. That's now where the signal chain has reached the point where you hopefully achieved what you wanted with it and can push it out to the audience. And that is pretty much the basics of a sound system. There's a lot of other details that we can go into concerning microphones. So your input stage, let me just go back to that one quickly. Your first stage is your input transducer. So just quickly to say as well, and many of you might have heard the terms, well, I'm not sure what you guys know, but you get different types of microphones like condenser microphones and dynamic microphones. And we'll get into more detail on these kind of things later on in the series, hopefully. We've got Ross speaking next week on the smaller parts of the sound system and the details of them. So your mics, your pickups, your DI boxes, those kind of things. Okay, so let's just look at the other things that a sound system also has. Cables, obviously, that I forgot to mention that. So all the stages, you'll obviously need cables. It's actually one of the more overlooked things in sound production, but I think it's very important, because if your cable sucks, then your signal will suck. So a very important stage in between all these elements is your cable. Cool. It's important to think of the size of your room when you're producing audio for an audience. Doesn't matter how big the audience is, even if it's for yourself. Do you think of the size of the room, or if outside or not? That will determine also a lot of the details of your sound system. One cool thing to note is that back in the day, when you looked at a musician on stage as the audience, you could visualize immediately where the sound is coming from. So the sound was kind of congruent with what you were seeing with your eyes. And that's important to note, because that gave obviously a cool experience for the audience. You had guys basically to where that sound is coming from. So you're looking at, say, the guitarist on the left side of the stage, but guitars panned completely to the right. Your brain will have to do a few more calculations to I hope I'm saying this right, but yeah, there needs to be a congruency with what you see and what you hear. And I think often as sound engineers, we overlook the fact that visual aspects are just as much a factor in the listener's experience. So these days, what we aim for with these systems to recreate that experience for the listener, what you see on stage. Obviously, for crowds like this, it's difficult, but your main aim should be to create an experience, or to serve your congregation if you're in a church, to create that experience for the listener. So you want to make sure that your panning is correct and that the experience that it's as good as it can be. And hopefully we can inspire you with that as well along the way. Cool. Thanks, everyone.
If you have a topic you'd like us to cover in a webinar of some sorts, you'll pop us an email there, training@stageaudioworks.com, and we'll do our best to put it together. We have nothing but time at the moment to do this kind of stuff. So yeah, let us know, and we'll try and accommodate it as best as we can.